Hello everyone. Today I want to discuss about image segmentation. So let's understand why we have to do image segmentation and why is it helpful. So the use case which I am taking here is of a scanned images. So let's understand what is segmentation first. Segmentation is nothing but dividing a digital image into multiple segments basically, right? So this is like an subpart of object detection which you see in image processing. So and in our case which we are considering the scanned image, so the segmentation is nothing but identifying the different text blocks in that particular digital image. And let's understand why do we have to do it. But before that, let's download some of the scanned images from the internet. I'm taking it from SlideShare. So if I read image, so CV2 has a function called imread, which reads any kind of image, like be it JPG, PNG, or anything. So if you see it here, so this is nothing but an NumPy array basically. It converts that image into an NumPy ND array, and this has a shape. It will have the height, width, and the number of channels basically. If usually any image will have 3 channels, red RGB colors, so it is represented as 3 channels here on the last dimension. And if you see the image, it looks something like this. And let's understand why do we have to do segmentation in this image. So our goal is to extract these two text blocks, right? So how do we do it? So we pass this text the scanned image to an OCR tool, either Tesseract or Easy OCR, any kind of OCR tool. We pass it and then it extracts the text. So the problem with OCR kind of tools is it always transcribe the text in a left to right order, right? So it's any OCR tool start with this first line. It extract this complete first line, then extract this complete second line at one go, and then so on and so forth, right? Now after extracting everything, if I have to separate this block with this block, you have to write some kind of rules, right? But it is very difficult to write rules to extract this kind of to separate out these two entities after we extract the after we extract the OCR basically. And that is one case. And another case is that another case is that we can improve the accuracy of OCR itself. So OCR sometimes what it does is it kind of makes mistakes in identifying different words in this particular image. So the idea is that if we pass a sub image, like the subset of image which we are looking for compared to an whole image, the OCR accuracy improves. The OCR transcription accuracy basically improves. That is another idea, right? Now first thing to do segmentation is we have to convert them into grayscale image. So why we are doing this is because, so for thing is any image has a 3 channels, but when you are looking at an scanned image, the color doesn't matter, in the sense everything, the characters are black in color and the overall background should be white in color. That should be sufficient for any analysis. So this could reduce some computational things. So that's the reason we could convert them into grayscale image, and then we convert it into a black and white image basically. So to convert any image to black and white, what you have to do is you have to choose a threshold, and anything greater than that threshold will be a black color, and anything less than that threshold will be a white color, right? So that's how you choose a threshold. But depending on the image, it is very difficult to come up with a threshold manually. Like it completely messes up the image if you are choosing a wrong threshold, right? So that's the reason CV2 has a very good method called Otsu threshold. So this Otsu threshold usually analyzes the image which you are passing to it, and it has basically at the background it has an algorithm which automatically comes up with a threshold which could where you could classify that into a black and white image, right? So I'll convert this into gray first, then black and white, and then see the image, right? So you could not really notice that this is a black and white image, right? But this is because of the matplotlib library. So it is, I'll show you by writing it to a file. Write image black and white. Okay, I think it should be first temp.png. Just writing it to a temporary file. So if I open it here, see, you can see here it has a black background and the white text, right? So now that's cool. Now next thing is how do we find out different text blocks in this scanned image, right? So there is an operation called dilation, right? So what this dilation does is, it's a simple thing. So when you keep on increasing the dilation iteration, what happens is all the texts which are closer to each other will kind of begin to overlap with each other to form a solid mass, right? So all these texts which are very closer to each other, they keep on overlapping with each other and then tries to form a solid block, right? So now let's see how after we perform dilation. So in this dilation, what we have to do is we first have to choose a kernel. What kernel is, so if I'm choosing a 5 by 5 kernel, the 5 by 5 kernel is nothing but a squared image, 5 by 5 square image, which is sliding over this image and doing that dilation operation basically, right? So now if I have chosen a dilation operation as iteration as 5, and I've chosen the rectangle 5 by 5 rectangle. Now if you see here, it what happened is it kept on overlapping all the characters to form a solid mass like this, right? Now you can clearly differentiate this block with the upper tabular block with another stamp which you are seeing here, right? So that is coming as another block, and the signature part is coming as another block, and so on, right? Now we have identified all the different textual blocks using dilation. The next step is to actually subset this text blocks basically, right? So there is a method called contour detection. What contour detection does is, so it will try to join all the neighboring images until it neighboring images which has which has the same intensity basically. When the intensity is when the intensity of the pixels is changing, then what it does is it kind of draws a shape around it till where it could match, and then it goes on to find another shape basically, right? So in this text, so what it does is it kind of finds that all these are neighboring pixels forming a shape, right? So this is forming a square shape, right? So then it draws this first square shape, and then because there is a pixel chain here, right? So because of that, it finds out this as one block, and this as one block, this is another block, and this is another block, right? So how do we do this? We've taken this, so you are finding the contours basically. So initially this is like you are basically taking, if you have a length of 2, you are taking the first input, and if else you are taking the 0th input, else you are taking the second input. So and you are trying to draw a bounding box. So bounding boxes around the detected text basically, right? If you see here, it has identified all the text blocks which are there, right? So now the problem is, because of this pixel changes here, these small things are identified as a smaller text blocks basically. So these are like this is because of the noise in the data. So you could programmatically actually remove these blocks. So because these are very small blocks, ideally what you can write is, you can write a rule here. So if width is less than 100, or so these are very chota boxes, so height is less than 50, so you say continue. So what happens now? Sorry, okay, you have to copy this because you're drawing on it. Right, so now you have eliminated all the smaller boxes and you could only detect the boxes which are of interest to us, right? So now you can what you can do is you can let me take let's write all the final blocks into final blocks equal to this thing, and final blocks dot append cnt. Right now we have all the final blocks. I'll take x y w h equal to cv2 dot bounding rectangle of final blocks of, let's say I'm taking the first block, right? You got right now, let's say I have an image, so I'm going from x, sorry, it starts from y2 y plus h comma x2 x plus w and this one. Now if you say plt dot im show this thing, right? So you are able to extract this thing, the first part. Now let's say if you are going to the second block, right, you could subset this image. So this image could be passed to the OCR layer and the OCR would give us the output, right? So that thing we'll see in the next video, how we can pass these images into OCR and then extract the text out of it, right? So